Okay, so I am recording the class. Okay, and again, I'll show you where these recordings will be available once the class is over. So if you want to go back and review anything we've discussed, it'll be there. Okay, so again, I'm going to go back to the modules section of our course. You can see the start here where you're going to begin. Okay, please make an effort to finish all of these short little assignments before Friday. Okay, not only do you have to attend the online sessions that we have, it's important to keep moving with the assignments. Okay, so try not to get behind. It's a lot harder to catch up than it is to just stay on a pace with the rest of the class. I kind of alluded to the fact you didn't have to pay for any kind of an access code to do homework problems, okay? And that's because we're using this homework system called MORE. It stands for Maricopa Open Educational Resource. It's totally free to you. You don't need to log into a different site. All of the assignments are embedded in Canvas. This is a little file that shows you, if you haven't used MORE before, and I know a lot of you have because you were my students in the fall, okay, but if it's new to you, take a look at this file and it will show you how to enter the answers, okay? And I'll show you that as well a little bit further down, just really quick. The last assignment that's due by Friday is a discussion board called Meet Your Class, okay? And again, just post a short introduction telling us your major, why you picked this course. And yeah, I know it might be required for your major, but elaborate a little. Tell us what you hope to use math for in your career, okay? And then if you're not recording like a video, okay, include a photo if you can, just so we can get to put faces with names, okay? You can see some folks have already posted, okay? And so I'd encourage you to please do that before Friday so we can get to know each other. Okay, and you can see these are all graded assignments. If it has a point value in Canvas, okay, it's going to be a graded assignment. Okay. The other thing I want to show you is what the rest of the modules look like. All of the modules have the same format. Okay, they have a week number. Okay, so here's week 1. A due date, January 24th. So all of the assignments in this module are due January 24th. Okay, I've broken it out by learning activities, okay? And the first thing in each of the learning activities is a link, a page that has our online session information. I'm gonna click on this just to show you where you can find this, okay? Monday was a holiday, okay? So we didn't have an online session on Monday. But here's our session for today. Okay, you can see it tells you what we're going to cover mathematically, when it is. There's usually going to be a meeting link here, okay, but you can get right into it from the Cisco WebEx tab in Canvas, okay, that's embedded in our course up here. And then once we actually are done with this, I'll post our video here, and any files like guided notes, I'll post here. Okay, so if you have to miss a class, let's say you have to go to training for work or you have something else important that can't be put off, okay, you can go back here and see what we covered. All right, and again, it's called live online sessions. There's one for every week of the course. Okay, the other learning information here are videos, a web page, and guided notes. Okay, so for each topic, you're going to see videos, web page, notes. Okay, basically, you can just kind of click on these to see the information. Okay, and then I am going to be using these guided notes as part of our online session. So a good thing to preview before the course session is to actually take a look at these notes and see what it is that we're going to be covering. Okay, I even encourage you, if you have a printer or, you have the ability to just download them, okay, you can download and print them and maybe even fill them in, and then they can become your notes for the course. Okay, so our first topic this week, okay? And we're going to cover both of them, okay? Even if we don't cover them completely in the time we have left, okay? I will upload completed versions of these notes. Okay, so we're going to look at solving systems of equations, and then we're going to look at applications of systems in business. Okay, there's also a text. Okay, this is a free online text. Okay, and again, it's certainly worth taking a look at if you want to look at it. Okay, I would not recommend downloading them because again, some of the chunks are pretty large. You could see this one's 23 pages, but it's certainly reasonable for you to look at it, at least skim it. And the virtue of an online text is in some cases, they're even searchable. Okay, if you want to look for a particular topic. All right, so there are the learning activities that again, you're expected to look at. Please do me a favor and at least look at the notes and the videos before you start the homework, okay? Otherwise, you're going to spend a lot more time on the homework than necessary. You can see there are 2 assignments in week 1, homework, and you'll be able to do both of these after class today. Okay, but let's just take a look at what this looks like. Okay, so this is this online homework system called More. You can see it connects automatically. You don't need to log into a separate place. Okay, I'm going to show you the teacher preview because that's what it's going to let me do. Okay, and again, here are some of the questions. Again, it's asking you to identify solutions of a system. Okay, again, it's a system of 2 equations, and you might remember from introductory algebra that that's going to be where they cross the 2 lines. So you're going to be looking at this system. You're going to say that's at x is -5, y is 1. Okay, and it says write it as an ordered pair. Okay, and again, a lot of times when you have an answer box here, you'll see like a little yellow edge to the answer box. If you click on that yellow part, it'll bring up a template, a math template, which will let you enter things like fractions, exponents, ordered pairs, okay? And it's much more efficient to use the template because you're sure you're entering it in the right way, okay? One thing that More does is it will tell you if it says syntax error or the form of the answer isn't correct. Take a look at what you typed, okay? What More is telling you is, I can't recognize it as anything, so it's going to get marked wrong, okay? All right, and again, what I want to show you down here, most of the questions have an attached video, okay, if you need some extra support while you're doing the question. And every question, every homework question has this message instructor link, okay? If it's taking you too long, what's too long? It's taking you more than 15 minutes to do the question, or you've tried it a couple of times and you keep getting it wrong. It's possible when you do a question and you get it wrong to try a similar one, reload it with new numbers, okay, so you can try it again. So if you've done that 3 times and you're still not getting the right answer, click this message instructor, and that will send me an email with your problem in it. And what I can do is I can actually walk you through the problem, but actually give it a try first, okay? Look at the video, try looking at your notes, see, make an honest attempt at actually solving it before you email me. But then if you're really stuck, email me, okay? So that's kind of a short review of how to do the homework. Okay. Anybody got questions at this point?
So what about exams and tests?
I'm getting to those, Fred. Okay. Let's go back to the modules. Okay. I'm going to scroll on down.
Sorry, I have one question.
Sure, go ahead.
For the More homework tab, we can retry the problems and it won't mark them wrong? Okay.
That's right. Okay, another thing, besides retrying the problems, another thing that comes with More that I kind of like, okay, you'll notice these have due dates. Okay, January 24th. What happens once the due date passes is more locks you out of the assignment, but it has a late pass feature. And I've given all of you 10 late passes. Okay, the late pass will open the assignment for an additional week. Okay, and you can work on the assignment for an additional week. If the assignment goes past that additional week, you'll need another late pass to open it up again. Okay, I'm trying to give you the ability to manage your own time. I realize stuff happens and sometimes it's not possible to get the assignment done in time. So I've given you the late passes so you can control assignments past the due date. Again, I'm going to encourage you, try to get them done by the due date because the class keeps rolling along and we don't want you to get overwhelmed by having too many assignments to do at the end, okay? And again, you've got only 10 of them. That's not enough to use one on every assignment, okay? So please try to manage your time, but you do have these late passes that will help you in case you miss a due date, okay? So let's scroll on down, okay? Oh, and also you can see there are sometimes calculators or apps that I'll put inside here, okay? And then I'll also note that there are sometimes discussions, okay? So please pay attention to what's in the assignment section, okay? It's not always just homework. Sometimes it's discussions. Sometimes it's something called a grade check. And what that is a way for us to communicate about how are you doing, okay? What do you think is still past due? What do you think your grade in the course is? This is to avoid surprises at the end, okay? So we have an ongoing discussion a couple of times during the semester about how you're doing and what you need help with, okay? Now let's scroll on down to our first exam, which you can see is here in week 5. Okay, so here's the questions about the exams. The exams are also in more, okay? And basically there's a practice exam, which we'll go over before the exam. I'd also encourage you to bring any questions you have about the material up to that point, okay? So we answer your questions as well as what I think are questions you should have, okay? So there's a practice, okay? And what I'm going to do to review it, see, this is one you can try before you take the exam. So I'm going to click on it, and you can see it's an actual more practice exam, okay? It's similar to the actual real exam. The only difference is this doesn't count for a grade. In other words, what I'm telling you is you can try it, okay? And no matter how poorly you do on it, this does not affect your grade in the class, okay? But this one does, okay? So make sure you pay attention, do the practice first, then try the real one. And you'll notice there's a Unit 1 exam work also for 0 points, okay? And basically, exam work is a picture or a scan of your actual work for the exam, okay? So this would allow me to possibly award you partial credit, okay? So again, since this is an online exam, you know how online programs are. The answer is either right or it's wrong. And it doesn't matter if you did the problem completely wrong or if you just had a rounding error at the end, it's going to mark it wrong. So here's your opportunity to get partial credit. Upload your work, either a scan or a photo of what you wrote down when you were actually taking the exam. There's enough time to do this, folks, okay? So please make sure you share your work with me, okay? So let me stop, okay? And basically, can you review the assignments after you get locked out? Yes. Okay, they're always open for review. Okay, so you can always go back and review them after the fact. And if you see anything that's not behaving properly, like it seems like you're locked out, please reach out and share that with me. Like, hey, I can't see assignment 1.1 anymore. What happened? Okay. So if anything looks like a glitch, ask. Okay, don't sit there and try to guess what happened. Okay, ask. All right, also, we have a post in the chat in case anybody wants to set up a study session. You're more than welcome to do that with each other. Okay, that's a great way to study. Okay, and I'll ask at this point if anybody has questions about exams. Okay, questions about exams? Okay, there are 3 like cumulative exams during the course and a final. I'm sorry, go ahead again.
No questions.
Okay, was somebody else asking? Okay. All right. No questions? Okay. Last thing I want to show you down here at the bottom, there's 15 weeks in the semester, and it will be gone before you realize it, believe me. Here's our final exam, which is also in more. Okay, it's set up the same way with work, and there's a kind of a, there will be an exam preview before that, don't worry. Okay, I want to show you this online tools and calculators module. It's near the bottom of the course. Okay, what I've done is any of the online calculators that I'm going to share with you are here as well. Okay, so you don't have to search through the whole course itself in order to find them. So here's general tools. I've got an online graphing calculator, which a lot of you are familiar with. It's called Desmos. I'll be using that today. And a science calculator, okay, called Web 2.0, okay, scientific calculator. These are in lieu of a TI-84, although I'm sharing a whole lot of resources with you. Okay, there's some matrix tools here, probability tools here, statistics tools here, and some multivariable tools here. Okay, so again, I put everything in its own modules to make it easier. Okay, last thing in the course is something that should be in all of your Canvas courses. This is from Student Services, and it's a list of resources. Okay, so technology resources, using Canvas. Okay, we in the Respondus browser, so you don't need to worry about that. Part of the reason I'm not using Respondus is because there are way too many online tools that you need to have access to while you're doing exams. Okay, there's some time management and study skills things here. Okay, and that in short is an overview of the course. Okay, so again, I'm not going to read the syllabus to you. Okay, I know everybody is capable of reading the syllabus and understanding it. There's a syllabus quiz over here. Okay, so again, let me pause and ask if anybody's got questions on the structure of the course. Anybody, any questions at all?
No questions at all.
Okay. All righty. Again, main thing is you're understanding what's going on. If you ever feel lost, please reach out. Okay. Okay. Well, what I'm going to be doing then is I'm going to be starting on the material. Okay, so I'm going to be using solving systems algebraically notes and solving applications in business. Okay, so this is a review for some of you. Okay, it should be a review for everyone because this is material that is typically covered in an introductory algebra course, but we're going to be using it, and I want to make sure you not only, it's not about learning how to do it by hand. Okay, we're going to use tools for actually solving a lot of the math in this class, but what's important is understanding what it tells you about a given business situation. So you're going to focus on how to set up a problem. We can use technology to actually solve it, but then we need to be able to understand what the solution is telling you about the business situation. Okay, so there's a fair amount of reading in this class. Okay, but that's the way business works anyway. Okay, so I'm going to begin by sharing some notes with you. Okay, this is going to take a minute to get started because I need to get another device to connect to my piece. Okay, give me a moment, and you should see the notes show up momentarily. Okay, and I have to share this content with you. All right, so everybody should now be able to see section 1.1, solutions to systems of linear equations. So just give me a yes or no. Everybody able to see that? Okay.
Yes.
Awesome. Okay, so solutions to systems of linear equations, what are they? Well, they're a set of equations. Usually there are as many equations as you have variables. Okay, usually if there are fewer equations than variables, you won't be able to get a unique solution. Okay, you'll wind up with a whole set, an infinite set of solutions. So here I have two equations with two unknowns, and you're familiar with what this looks like. Okay, this kind of looks like two lines that may or may not cross at an ordered pair. And here I have three equations and three unknowns. You can have four equations and four unknowns, five, and so forth, right? This still has a physical interpretation. Okay, you can think of these equations as a plane in space. Okay, and basically, what does this kind of look like? You might think of it as looking like, think of it like this, and then here's the third plane. Okay, so they all intersect at a point in space. This would be a triple x, y, z. Okay, and that's if it has a unique solution. Okay, everybody, when they solve systems of equations by hand, they hope, oh, I hope I just get one answer, right? And it's important to realize that that's not the case. Okay, more variables will give you more equations, but then once we get beyond three, we can't really have a visual representation of it. Why is that? Well, we exist in 3 dimensions, okay? And any more dimensions are kind of hard to visualize when we're walking around in a 3-dimensional space, okay? So we're going to stick with usually 2 or 3 variables, okay? And solutions to them include values of the variables, say xy or xyz, that make all the equations true at the same time, okay? And here again, I'm showing you what solutions a unique solution would look like: ordered pairs for this system, ordered triples for this one, okay? There are a couple of ways of solving systems, okay? And again, there's a graphical method, there's an algebraic method, okay? And nowadays you can even solve them with apps, okay? So let me show you solving graphically. I'm going to go through this once by hand, and then you're going to use a graphing tool, and I'll show you how to use Desmos, okay, which is my graphing tool of choice, to actually do it, you know, automatically, okay? What do I like about Desmos? Well, you see these equations? This first one is in what's called standard form, where you have variables on one side, the number constant on the other. This one is in slope-intercept form. The TI-84 requires all of your equations to be in slope-intercept form in order to graph them. Desmos doesn't. So I can type these 2 equations just the way they're written in Desmos. Why is that important? Because it's obvious that the more manipulation you have to do, the more possibility there is to introduce an error, right? My algebra is pretty good, so I'm pretty sure I can solve this equation for y. But if I make a mistake, then whatever I've typed into my TI-84 is wrong to start with, okay? So that's one reason why I prefer Desmos. The other reason is it's real easy in Desmos for me to just tap on a point and get the ordered pair. In the TI-84, I have to go through the calc menu. I have to use intersect. I have to set bounds on the intersection. It's far more tedious. Okay, so Desmos is easier to use. Okay, so that's my pitch, and I'm promising I'm not getting a kickback from them or anything. It's just a really easy calculator to use. All right, so let me show you how they tell you to do this by hand. We're going to do it once. Okay, write each equation in slope-intercept form. Well, this one's already in slope-intercept form. How do I know that? It's solved for y. So I have to take the first equation and solve for y. Okay. Again, there are multiple ways to graph by hand. And this is telling you how to do it. You can either plug in points, okay, plug in a value for x and solve for y, or write them both in slope-intercept form and then use the intercept and slope to graph. That's the way I'm going to do it because it's faster. Okay, so I'm going to use this method. All right, now to solve for y, let's get rid of the minus 2x. Right, I'm subtracting it because it's a positive term. Okay, the 6 was positive. I could tell because there was no negative sign in front of it, so I had to put a positive sign. Again, you don't always have to say 6 minus 2x. You could put the negative 2x first as long as you take the leading sign with it. Okay, on this side of the equation, 2x is negative. So whether it's after the 6 or before the 6, it should have a minus sign in front. Okay. Last step, divide by 3, divide every term on both sides by 3. Okay, this is more efficient than just drawing a big line and dividing by 3. Just divide it term by term. This gives me 1y equals negative 2/3 x plus 6 divided by 3. That goes even. Okay, so now I have a slope and a vertical intercept. Okay, vertical or y-intercept. Okay, why am I saying that? Because it won't always be y as your variable. Okay, sometimes it'll be another value. Okay, so everybody okay with getting that in slope-intercept form? Okay, blast from the past. Okay, everybody good with it? All righty. Well, now that we have it in slope-intercept form, what are we going to do with it? Okay, well, I'm going to take both these equations. I'm going to write them again just so I can see what I have. Y equals 4/3 x minus 4. That's one equation. And the other equation is y equals negative 2/3 x plus 2. Okay, and the way you handle this, okay, I'm going to start by, let me draw some axes here. Okay, so here's y, here's x. Okay, let's just assume all of the marks are 1. Okay, so this is 1, here's 2, and so forth. Okay, so let me graph the first one. I'm going to start with the vertical intercept. So negative 4, negative 1, negative 2, negative 3, here's negative 4. And then I use the slope, a second point on the line. Okay, remember slope is rise over run. So this is saying go up 4, up because it's positive, okay, and go to the right 3 because this is positive. Whenever I use the slope, I always put the sign of the slope up in the numerator, okay? That keeps me from running backwards on x. So I'm always going to run to the right with x and the sign in the, whether I go up or down, okay? So this slope's positive. So it's saying go up 4 and over 3. Okay, so another point on this line is right here. Okay, so this was up 4 on the y-axis and over 3. Remember, the top is up, down, the bottom is left, right. Okay, so now I have 2 points and I can connect them with a line. Okay, so there's my first line. The second line, okay, has an intercept of positive 2 on the y-axis. So I'm going to go up to 2 on y. And that slope's negative. So that slope says go down 2 and over 3. And I wind up with, well, wow, the same point. Okay, that same point, 3, 0. So here's my other line. Okay, and again, we can see the point where they intersect. Okay, the intersection point. Is the solution, and that's the point 3, 0. Okay, and it says determine where the lines intersect. Okay, everybody kind of remembers how that works. All right, now it's possible that you can wind up with a pair of parallel lines, in which case there's no solution because they don't ever cross. Or you can wind up with lines on top of each other, in which case they share all of their solutions. Okay. Now, let's do this one with Desmos. Okay, so I have one equation that's in standard form, and I have another equation that's in standard form. Okay, so if I were doing this on a TI, I would have to solve these both for y. I'm not going to do that. I'm just going to go to Desmos. Okay, so I should still be sharing my browser with you. So as soon as I minimize this application, you ought to be able to Desmos. Okay, so let me just go here. Just need to get the chat. So minimize this. Here's Desmos. Oops, Desmos. Okay, so I'm going to minimize that and get my chat over here. All right, so the two equations, okay, one thing Desmos has is it has this little keyboard down here for those of you who aren't familiar with it yet. And what's in here are ways to do squaring or raising to powers. If you click on ABC, you've got all kinds of brackets and symbols and things, okay? Most of what you need is actually on your keyboard, but if you need functions that aren't on your keyboard, you've got them over here, okay? So we can do a lot of things in Desmos. But for now, I'm just going to minimize this keypad. I just wanted to show you that it was there, okay? So all I'm going to type here are the two equations, which were 2x plus minus 3y equals 3. Okay, and notice standard form, I didn't have to do anything to get it to graph. Okay, now I'm going to click on the next spot. You can also down arrow, okay, to get here, but get a second line over here. All right, this one's going to graph in red. The next one should graph in blue, and that's x plus y equals 5. Okay, so there are my two equations. Okay, now let's, first of all, notice I can drag just like on an app on a phone. Okay, you've got zoom in, zoom out. You've got the ability to set your graph, okay, your x-axis and y-axis. But in most cases, you're just going to click and drag or zoom in, zoom out. Now, in order to see the solution, all I have to do is click. And I get 3.6 and 1.4. Okay, now if you need those as fractions, well, you've got to convert them to fractions. And there are fraction converters that I'm going to share with you as well. Okay, so you can convert decimals to fractions and whatnot. Okay, but there's your solution. Notice Desmos also shows you intercepts. There are x and y intercepts. Okay, and if this had been a curve with a high spot or a low spot, it would have showed you that as well. Okay, so let me ask over here questions on Desmos. Okay, anybody have a question on Desmos? Anybody want to see it on a TI? Anybody want to see it on a TI? Okay, I'm getting a yes. right, so let me share my TI emulator with you. Okay, let me get the chat box out over here first. And I have to share some more content. Here it is. Okay, everybody should see a TI-84 on the left-hand side of the screen. I'm going to turn it on. Here. Okay, so the first thing I need to do if I want to graph on a TI is I have to be able to write these in y equals form. Okay, so let me just go back here and I'm going to solve these for y. Okay, so this is 2x minus 3y equals 3. So I'm going to subtract 2x minus 3y equals negative 2x plus 3, and then divide by negative 3. And that gives me 1y equals, remember, negative divided by negative is a positive 2/3, and then positive divided by negative is a negative 1. Okay, so you have to do that part manually if you're going to use the TI. Okay, and then over here, I have x plus y equals 5, and I'm just going to subtract x. Y equals negative x plus 5. Okay, so here are the two equations I'm going to graph in my y equals. And again, remember, I don't need the 1 as a coefficient. I'm just showing you that negative 3 divided by negative 3 is a positive 1. So here are the two equations I'm going to graph on my TI. Maybe with any luck, I can slide this over. No soap. Okay. All right, so write these equations down if you're interested in seeing how to do it on a TI. Okay. And I'm going to minimize this and show you the TI. So I'm going to go to y equals. And again, my first equation was 2/3 x minus 1. All right, here's another trick with a TI. You probably didn't realize that you can put in fractions, okay, in your TI. Okay, you need to use this alpha key. See this green key? It may not be green on your calculator, but everybody has an alpha key under second. So type alpha, y equals, and it brings up this little menu. Okay, the first one means numerator divided by denominator. In other words, a fraction template. So I'm going to hit enter. And now I can type in 2/3. Here's my slope for that first equation. Okay, and I didn't have to worry about parenthesizing it or doing anything weird with it. Okay, it just is a fraction like it's supposed to. Here's the x. Okay, and the intercept was -1, so -1. So there's my first equation. I'm going to arrow down. Okay, the second equation is -x. So remember, that's a leading negative sign, not a minus. So we have to use leading negative x. And the intercept there was a +5. Okay, now I want to see that on a standard window. So I'm going to click on zoom and 6 for Z standard. That puts it on a 10 by 10 screen. Okay, and you can see we're getting the same graph, right? And now you want to find this intersection point. So that's on the calc menu, which is a shift above your trace. Okay, so blue second, calc, and then you want to use intersect, number 5. Okay, now all you have to do once you do this, because it's prompting you first curve, just hit enter 3 times. Enter first curve, enter second curve, enter yes. And you can see we got the same values that we got here, 3.6 and 1.4. Okay, everybody okay with the TI? Okay, I think you'll agree, though, it is easier to use Desmos. Okay, it'll be especially easier to use Desmos for inequalities which we'll talk about a little bit later. Okay, so please try to get comfortable with Desmos. It'll save you a lot of aggravation. Okay. Everybody good with this? Okay. All righty. I'm going to go back to the notes. All right. And again, we had the solution as, what was that, 1.4 and 3.6? 3.6, 1.4. Okay. Now that's solving it graphically, and in most cases that's fine. Okay. The problem, again, is if your graphing tool isn't giving you enough precision, or you need it in exact form, say like a fraction or a square root, then you're kind of stuck with doing the algebra, aren't you? Okay. So here's walking you through using substitution. But before I do that, okay, I'm going to say up here, if the lines are parallel, there's no solution. If the lines are the same, there are an infinite number of solutions. Okay, just as a review. Okay, so if we're going to be doing this, okay, you might remember substitution requires you to solve one equation, okay, for one of the variables. So when you're looking for substitution, look for a variable with a coefficient 1. Okay, 1 or negative 1. Why is that? Why do you think? If I'm going to use substitution, why should I look for coefficients of 1? Okay, why look for coefficients of 1? If you're going to solve for that variable, what does it eliminate? Think about solving a linear equation with a coefficient bigger than 1. What's the last step? Anybody have ideas? Okay, if you're trying to solve a linear equation and you've got a coefficient that's bigger than 1, your last step is to divide by that number, right? If it doesn't go into things evenly, you just made a mess of fractions. Okay, and equations with fractions in them are hard to solve. So if you're going to try to solve for a variable here in terms of the other variable, try to look for a variable that's got a 1 as its coefficient, like this y right here. Okay, that way I avoid the divide. And making fractions. You avoid dividing and making fractions. Does that make sense? Yeah? Okay, so when I look at this system, I know right away I'm going to solve for y in that first equation. Okay, so to solve for y, I'm going to subtract 4x from both sides. Okay, that gives me negative y equals, here I'm just going to leave it like this. All right, I'm not solved yet. Okay, because I need to divide everything by negative 1. Okay, that gives me y equals negative 3 plus 4x. And if I want, I can rewrite that with the 4x first and the negative 3 second. That's equivalent. Okay, as long as you take the leading sign in front of the term, you can reverse them if you want. Okay, so now I just take the second equation, and this is solved for y in terms of x. So whenever I see y in the second equation, instead of putting in y, I'm going to say 4x minus 3. Okay? Everybody good with that one? All right, and then solving it is just algebra. The first thing I need to do is distribute the 3. So 3 times 4x is 12x. 3 times negative 3 is negative 9. Then you see I have some like terms I can combine. All right, and now I want to solve for x. And I can solve for a number by just adding 9 to both sides. And then last step, divide by 14. All right, so I have my x value. And then in order to get y, I use this original equation that I created where I have y in terms of x, and I just plug my number for x back into that. So I have y equals 4x minus 3, y equals 4 times 2 minus 3. Okay, and 8 minus 3 is 5. So my final answer as an x-y pair is 2, comma. Okay, so that's how you do it with substitution. Okay. Elimination is when you don't have a coefficient of 1 anywhere. Okay, so how do you decide whether you use substitution or elimination? If I see any of these variables with a coefficient of 1 or negative 1, I know I can use substitution. Okay, you can use substitution or elimination on any system. It's just a matter of making it easier on yourself if you're stuck doing this by hand. And not to worry, okay, we're going to pretty much use matrices to do this, so we won't be stuck doing this by hand for very long. Okay, quick review of elimination. And again, I want to get through the algebra stuff quickly because I know it's a review for you. I want to talk more about applications. Okay, so I'm probably not going to get through all of the notes for this section, although I will upload them with solutions so you can see everything worked out. But I want to get to the applications. So let's just review when you use elimination. Notice here, none of these variables have a coefficient of 1. So I can't really easily use substitution. If I solve for y, I'm going to maybe get things that are fractions that I don't want. Okay. Some of you are looking at this saying, this will work because 9 divides evenly by 3. Yeah, you could do that. Okay. So the trick is you can always use either method on a system. It's just one way is easier than the other. Okay. So for a system like this, I'd use substitution. The idea is the same. You want to get one of the variables to drop out. How do you do that? Well, you want to make it coefficient 0. Okay. Well, the way you do that is you want to get the same number, but with opposite signs in front of each one of these. Okay. So I can either multiply the bottom equation by 9 and the top one by negative 11. That'll make both of these like negative 99, positive 99. That seems kind of large. Okay. Notice that on y, these are already opposite signs. So that looks like it's easier. Okay, pick the easier one. Number 2. Okay, so it's easier to get rid of y. Okay, so y is the easier variable to get rid of because the signs in front of the y's are already reversed. You don't have to multiply by a negative number. Okay, so these are both in standard form. I've determined that y is the easy one to eliminate. So I need to multiply. What do I want to do? I want this to be negative 6, that to be positive 6, right? So I'm going to multiply my top equation by 2. Okay, and I'm going to multiply the bottom equation by 3. How did I figure that out? Well, 6 is the smallest number that both -3 and +2 go into. Okay, so that's how I picked it. If you always reverse these coefficients and multiply, say, top one by 2, bottom one by 3, as long as the signs are opposite, okay, that'll work too. You just may get bigger numbers than you need. Okay, so let's take a look at this. This one is giving me, okay, having some trouble with my iPad, sorry. 18x minus 2 times 3y is -6y equals 48. And this one is 33x plus 6y equals 3. Now, what you wanted to happen was this. That's kind of what drove the whole process. Okay, you wanted these to be same number, opposite signs. Now you add these equations, and the y will drop out. Okay, the 18 plus 33 is 51x, and the 48 plus 3 is also 51. Okay, last step, divide both sides by 51, and you get x equals 1. Okay. To quickly get the y, again, adding the two equations, okay, you get 51x equals 51, x equals 1. And then all you need to do is pick one of those two equations, either one. You decide which one's easier. Say 9x minus 3y equals 24. Okay, I just like the smaller coefficients. And then you plug in your value. 9 times 1 times 3y equals 24. Okay, and that gives me this. The rest is just algebraically solving. And I get y equals -5. Okay, and the final answer, again, is an xy pair, which is 1, negative. Is there any reason you couldn't solve this graphically? Absolutely. Solve it graphically and check. Okay? I know a lot of students get stuck in either doing things graphically and they never look at the other way. The idea is to look at both ways, okay, and try to make sure it makes sense. Okay, you should get the same answer from both. Okay, so that is a really, really quick review. Solving algebraically. I want to move on to applications, but just let me ask if there are any questions on solving systems. Anything in the review that you want to ask about? Anybody have questions? And again, the rest of this I will be happy to upload for you with solutions in them. Okay, I'm not seeing anybody with questions. Is that true? Good. Okay. Applications, and I want to make sure everybody has these basic concepts down, because again, I don't know what business or economics classes you've all taken. It's usually the case that folks are in different places by the time they get to MAT218. So I'll share some of these with you. Okay, so again, profit, okay, is revenue minus cost. Okay, and revenue is what? What's revenue? Somebody want to tell me? You can unmute yourself or you can type in the chat. What's revenue?
It's like how much money you make off of something.
Right. Okay. You can think of in product sales. Product or service sales. You know what I mean. Okay, money in. Cost are your expenses, right? Okay, so profit is the amount left over taken from selling your product or your service after you've paid your expenses. Okay? Costs are made up of fixed costs and variable costs. Somebody want to tell me what a fixed cost is? Accounting majors? What are your fixed costs?
It do not depend on quantity made.
Okay. Somebody want to try variable costs in contrast? What are variable costs? So fixed costs would be things like maybe rent or utilities, like maybe a capital expenditure. How about variable costs? And again, I know I'm using an accounting term here. Let me change it. Amount we pay. Okay, so while I'm writing this, you think, what's a variable cost in contrast to a fixed cost? Okay. Anybody have any ideas? Fixed costs, again, are things like machinery. Okay. Basically, things that
Building,
don't. Go ahead.
building rent,
Rent.
building rent.
Okay. Rent. Okay. These don't depend on how much of your product or service you make. Let's call it a product for now. They're fixed. Okay. Well, then that must mean variable costs do depend on how much of the product you make. Okay, so that could be things like supplies, right? Whatever the product is made out of. It could be labor, maybe utilities. Okay, I don't mean just keeping the lights on in the factory. I mean the utilities to run the machinery. Okay. Okay, beyond keeping the lights on. Does that make sense to folks? Any of you accounting folks want to, chime in and elaborate on that? Anybody? No? Okay. All right. The equation we didn't go over here is revenue. Okay. Revenue, the money in, is your price per unit times how many you sell. Those of you who've had me before know my banana example. Okay. If my bananas cost 10 cents a piece and I sell 8 of them, what's my revenue? Well, it's 10 cents times 8 or 80 cents. Now, the trick to all of this is number of units is typically a variable. Like X. It won't always be X, sometimes it's Q. Okay, but number of units is typically a variable. So if I had a revenue as a function of X, I'd have my price, okay, which is also a function of units, times another X. Okay, here, my fixed costs are just a number, however much I paid for my machinery, what it's worth. And my number of units here, the variable cost is going to have an X in it because it's dependent on how many I make. Okay, that's what this is all showing you. Okay, so let's take a quick look. Okay, and I realize we're coming up on the end of the session. Don't worry. Okay, suppose your cost function, C of X, is 5X plus 250. In C of X, what's the variable cost? What term is the variable cost? Okay, in C of X, what term's the variable cost? Now, 5X, because it has an X in it, it's dependent on how many my products that I make, and that's the variable X. Okay? They tell me the revenue function is 27X. That means each of my things is, let's assume this is in dollars, $27 a piece. Okay? So my profit function is revenue minus cost. Okay, and I'm just going to do it like this, 27X. Now notice my cost function has multiple terms in it. You need parentheses around your cost function. That makes sure that the negative sign, the leading minus sign, distributes to both terms. Okay, so that is 27X minus 5X minus 250. Notice how this has to be negative, right? Because you're distributing to both terms, right? And then again, combine your like terms to get 22X minus 2. Okay, the slope of the profit function is the coefficient on X. Okay. So it's, and what that means is for each additional one of your items you make, your profit goes, and you make and sell, your profit goes up by 22 bucks. Okay. So basically it says marginals. Somebody, what marginal means? What's marginal?
So marginal profit is how much more profit you will earn if you sell another unit.
Good for you too, Yen. How much more profit you earn if you sell one more unit? I'm going to write down what she said because it was great. Okay, that's exactly what it is. And I just told you that's 22 bucks. Okay, so in this example, marginal profit, it's the slope of the linear profit function. Okay, so in this case, it's $22 per unit. Okay, notice it has rate units on it. There's a numerator, dollars, and a denominator, units. Okay, because slope always has rate units. Okay, you may remember from a brief calculus that for nonlinear functions, you had to take the derivative at a point to find the marginal value, right? Because the slope is always changing as you move around the function. Okay, so again, just trying to make sure everybody is good with this. Again, part of what you need to be able to do in order to answer questions is, we've got like maybe 5 minutes left. Quickly move along. I'm going to show you some word problems that we can use to try to figure out how to set up a linear system. Okay, so here are some word problems. Okay, the tech giant company produces two models of laptops, a basic and a pro. The basic model requires 12 labor hours to produce, and the pro requires 18 to make. The company has a total of 360 labor hours available each week for laptop. The weekly capacity of Tech Giant's manufacturing plant is 25 laptops total. How many of each type should Tech Giant produce in order to use all the available labor and plant capacity? Okay, so here's a word problem. And I'm telling you in advance, this is something you can solve with a system of equations. Okay, so the first thing you want to do is decide your variables. Okay, so let's call our basic models X. That's how many of those we're going to make. We don't know what that number is yet. We're going to figure it out. And let's call the pro models Y. Okay, if you read through the problem a couple of times, you'll see we are talking about labor hours to make things. Okay, and here's the total. Okay, so we have kind of a labor, okay, and then we have a capacity. Let me switch to color on this. Okay, weekly capacity of Tech Giant is 25 laptops. That means for both kinds, okay? They're not saying I can only make so many of this and so many of that. Total. So if you want to think about it, you've got a situation like this. We've got basic laptops, which we're calling X. We've got pro laptops, which we're calling Y. Okay, and then we have two categories. We have labor and we have capacity. And then, of course, down here we've got totals for both labor and capacity. Okay, if you can set up a table for these problems, it's real helpful. Okay, so first let's take a look at labor. The basic model requires 12 labor hours to produce, and we're making X of them. Okay, so the total number of labor hours for all the basic models is 12X. Right? 12 hours for each one, and then we're making X. So say X is 10, okay, then that's 12 times 10, that's 120 hours. Okay. The model requires 18 hours to make, and we're making Y of those. So the total number of hours on pro models is 18Y. Okay, and we're also told there's a limit on how much labor we have available. We have 360 labor hours. Okay. Capacity is 25 laptops total. Okay, well, that's easy. I'm going to make X of the basics and Y pros. Okay, and then all you need to do is read down in each of these columns, and you've got a labor equation that looks like this. And you have a capacity equation that looks like this. Okay? And again, you can solve this system manually with substitution. Solve Y here, and then substituting back here. You can graph it with Desmos and figure out how many X's and how many Y's should we produce to use up all the labor and capacity. Okay? Notice, I'm not solving it. The important part is the setup. Okay? And if you were to get an XY value, okay, this would tell you the number of basics and the number. Okay? Everybody understand what the answer would tell you? Okay, so again, I'm not focusing on the algebra, focusing on how to set up the problem. So let me ask you questions on setup. Anybody have any questions on the setup? I will show you how to do this one and the other one, and I'll upload it with the notes. But again, we're kind of running out of time, so I want to give you some time to ask questions if you need to. Anybody got any questions? Okay, I'm going to come back to the meeting and ask if you've got questions on anything. Anybody have questions on anything that we covered?